Hello learners. Welcome to a new course on the TypeScript tutorial. From this video, we will deep dive into the fundamental and advanced concepts of TypeScript. Along with that, we will look into various coding demonstrations, which will make your learning journey smoother and easier. This course is completely beginner-friendly, but to learn TypeScript effectively, you need to know some fundamental concepts of JavaScript. Some important JavaScript topics you should know are JavaScript introduction, variables and data types, functions, objects, case statements, loops, promises, and oops concepts. If you want to learn them, no need to worry, I have already uploaded the entire JavaScript playlist. You can either watch the full playlist or focus on these selected topics. Stick to this video till the end. If you are new to this channel, I would request you to please subscribe, like this video, and share it with your friends. So, let's get started. Before we dive into what TypeScript is, let's first understand how useful it really is. Did you know that most popular JavaScript library, which is Angular, is built using TypeScript? Not just Angular, even modern frameworks like Next.js prefer TypeScript over plain JavaScript. This clearly shows that TypeScript is becoming the preferred choice for many developers. But why is that? Let's find out. TypeScript is a syntactic superset of JavaScript, which means it includes all features of JavaScript, but also adds static typing. Because it's a superset, any valid JavaScript code will also work perfectly in TypeScript. The key difference is, TypeScript allows developers to add types, like string, number, boolean, etc., to their variables and functions. This gives TypeScript several advantages. Better code maintainability. Early bug detection. Full compatibility with JavaScript. Strong static typing. All of this makes TypeScript more powerful and easier to use in large or long-term projects. Let's understand this with a quick demonstration. We'll start by writing a simple code snippet in a JavaScript online compiler. Here, we've created a variable named age and assigned it the value 23. Later, we updated the same variable with a string value, Amit. When we use console.log, the output shows the updated value as Amit. This shows that JavaScript doesn't care about the data type of a variable. You can assign a number first, then change it to a string, and JavaScript won't complain. But this kind of flexibility can sometimes lead to bugs, especially in large applications. This issue can be easily avoided by using TypeScript. Let's see how TypeScript handles the same situation. Here, when we are trying to update a number type with string, it throws an error. This is called implicit assignment. Not only this, but TypeScript also provides us the feature to explicitly define the variable type, which is called explicit typing. Anytime if we try to update the value of variable with some different type, then it will throw error. There are very long list of advantages of using TypeScript. When it comes to disadvantages, there is only one disadvantage, that we cannot directly compile a TypeScript. For that we need to first compile TypeScript into JavaScript. Before installing the TypeScript compiler, let's first install our text editor. As a text editor, I will go with Visual Studio Code. You can also choose any other text editor as per your comfort. Click on your operating system and then download your Visual Studio file. Wait till the VS Code file gets downloaded. Till then, open a new tab and let's download Node.js. Type the URL nodejs.org and then download the latest version of Node.js. Our VS Code is downloaded, now it's the time to install it. Follow the exact same procedure and we are good to go. As you will finish the installation process, your VS Code will get open. You can select folder in which you need to work. Right now I am inside TypeScript_what folder. Let me create one HTML file with .html extension and another TypeScript file with .ts extension. Now we need to install Node.js. Node.js installation is also simple, just you need to follow the exact same steps. Our Node.js installation is done, but why do we need Node.js to run TypeScript? As in the previous video, we have seen that we cannot run TypeScript directly in our JavaScript. For running TypeScript, first we need to compile TypeScript file into JavaScript file. So, to install and run this compiler, we use Node.js and its package manager, npm. Now, as a next step we need to check whether Node.js is properly installed or not. For that, open your VS Code and in the terminal, type node-v. You will get the version of your Node.js. Secondly, also check the version of your Node package manager, which is npm-v. Done. Our Node.js and npm is perfectly installed. Next, we need to install TypeScript. Type npm install-g TypeScript. This command will install TypeScript globally into your system and thus, you don't need to repeat this step again. Finally, we need to install TypeScript compiler, which will convert our TypeScript file into JavaScript. For that, type npx-tsc. Now we are ready to write our first TypeScript code. Let's do it. Yes. No need to get surprised. TypeScript is JavaScript only, but with some extra features. After you have written your code, again go back to terminal and compile your TypeScript file to JavaScript. Look very carefully, as we will compile our TypeScript file, a new JavaScript file will get created. There we go, we have successfully written our first TypeScript program. Let's add something more to it. Here is a quick question. You need to define two variable name and age of a person, and you have to print the output in the given format. Let's try it out. Our code runs absolutely fine. You may see in your TypeScript file, it is showing 2 errors. For now you can ignore those 2 errors, as it will not affect your code compilation. If you want to remove the error lines, you can simply use @tsignore comments before each error lines and the error will disappear. In TypeScript, when it comes to creating a variable, there are 2 main ways of assigning a type. The first one we have is explicit type. These type assignments are easier to read as type is clearly written beside the variable when declared. And the second one we have is implicit type. These type assignments tells TypeScript to guess the type of a value a variable contains. Let's see a quick demonstration of it. First, starting with type number. The second type we have is type string. The third type we have is type Boolean. The fourth type we have is type undefined and null. Next, let's look at implicit type assignment. Here, no need to specify the type. Next, let me show you something special. Here, we have taken a variable of type number and then we are trying to modify it with type string which results in error. But, we have a special type which allows you to change the type of any variable. Here is how. The type name is any. We will look at this type in more details in upcoming videos. Next, let's discuss about TS configuration file. Before that, let me show you a scenario. First, we will delete our JS file and write some code. As our TypeScript code contains error, which is we cannot add a number type variable with a string. So, as we will compile our TypeScript code, it should throw error and should not create the JavaScript file. But, opposite of it, when we compile our TypeScript code, it creates a JavaScript file, even if it is wrong. Creation of JavaScript file is a problem because, after JS file is created, we can easily run the code and there will be no use of using TypeScript. Thus, we have TS configuration file. Type TS in it in your terminal. A tsconfig.json file will be created. After that, search for no emit on error and set it to true. Let's try running the wrong TypeScript code again. First, delete the JavaScript file. As you can see, this time no JavaScript file is created. Any is a data type which disables type checking. You can assign any value to it, whether it is number, string, boolean, object, etc. On using any TypeScript will never throw any error, even if you try something wrong. Let's see an example of it. You can see on replacing the value of number type with string, it shows error that string value could not be assigned to number. TypeScript shows error even before compiling. This is also one of the benefits of using TypeScript. Now, as soon as we specified the type of num variable as any, the error disappeared. Our code runs absolutely fine. You can see that earlier our variable was of type number, then it got replaced to type string, and then it got replaced to type boolean. And on replacing our variable value with different types, our code ran absolutely fine. Similar to any, we have one more data type, unknown. Unknown is similar to any data type, but it is considered safer option. You can assign any value to it. For using unknown, you must first check its type. Let's see how. In our previous code, I replaced any with unknown. You can see that our code runs absolutely fine, giving the exact same output as before. But, what is the difference between any and unknown? Let's look more closely. Any turns off type checking, but unknown forces you to check the type before using. Let's understand this with an example. In this example, as you can see, there is an error line displayed when we are using the type of num as unknown. Which is correct because we cannot apply to uppercase method to a boolean. But, when we change the type of num from unknown to any, the error disappeared. So, in real-life scenarios, you must consider using unknown, as it is the safer option than any. Now let's see how you can check unknown before using it. Let's explore other data type, which is big int. Normally in JavaScript TypeScript, we use number to store numeric values. But there's a limit to how big a number can store, which is to raise to power 53-1. If you go beyond this limit, the number becomes inaccurate. Thus, big int is used to store very large integers accurately. Let's see how we use it. It is necessary to use n at the end of your big num, as it differentiates between your number and big int. Here, we can see an error that big int literals are not available when targeting lower than ES 2020. This means we need to make some changes inside our tsconfig file we have initialized in our previous video. If you have not seen the previous video, you can click on the I button above. Here, we need to change our target ES version to 2020 or above. Now, there are two ways you can compile the TypeScript file. First, by simply using tsc. Second, you need to specify the target version while compiling your TypeScript file. You can also perform various arithmetic operations with big int as well. Next data type we have is symbol. Symbol is a primitive data type which is used to create unique identifiers. Even if two symbols have same description, they are never equal. Let's see a quick demonstration of it. Two symbols with same description are also not the same. TypeScript automatically figures out the type of a variable, even if you didn't tell it. This behavior of TypeScript is called type inference. But how? Let's understand with an example. In this example we have taken a variable, channel, in which we have not specified its type, but TypeScript is smart enough and it has automatically categorized this variable as string by looking at its value. Similarly, when we take number without specifying its type, TypeScript smart categorization categorized it as number. Let's try this with big int data type. A quick alert for you. However, TypeScript has ability of type inference. It is always recommended to explicitly define the data type of any variable to avoid errors. Now, let's learn functions in TypeScript. Same as JavaScript, a function is a block of code that performs a task. In TypeScript, you can define functions just like JavaScript, but with type safety. Let's see some coding demonstrations. Well, similar to variables, for functions also we need to explicitly define the return type. In this case it is not returning something, so the return type is void. Now, let's learn how to write flat arrow function in TypeScript. Here is how you can write function for return type string without passing any parameter versus with passing a parameter to the function. Now, I have some practice questions for you. Pause the video and solve it. You can also comment down the solution. In this question, you have to pass two numbers as parameters and return the sum of it. Our code runs absolutely fine. Let's jump on to the next question. Again, pause the video and try to solve it. If you are done, please comment down with the timestamp. In this question, we have to return Boolean value true when the parameter number is even and false when it is odd. The code is working fine. Let's switch on to the next question. Try to solve this question. If you are done, please comment in the video with timestamp. In this question, you need to write a function that will print the factorial of a number. Oops. There is something wrong, I guess. Let's fix it. There it is. The loop should run till I less than equal to num. Fine, our code is giving correct output. Now, let's see how we write default parameter and optional parameter in the functions. We have a function with a string variable as username. Right now we are passing a string value Amit. To make username variable a default parameter, you need to declare a default value to it that will get automatically assigned to it when no value will be passed. Like, here we are giving a default value as guest. Now, when there will be no value passed to the welcome function, the value of username will be automatically set to guest. Whereas, when we will give any value while calling the function, the value of username will be as per the value given while calling the function. Next, we have optional parameter. We will copy the same above function and paste it. Now, we will add one more parameter employee ID to the welcome function. To make any function optional, you simply need to add a question mark after the variable name and all set. Employee ID variable is optional. You can assign any value to it or call the function without assigning any value. Both will work fine. Let me show you how. Here, we are calling welcome function twice, one without giving the value of employee ID while other giving the value of employee ID. Boom! Our code works absolutely fine. Arrays in TypeScript is similar to that of JavaScript. If you are new to array, you can continue watching. An array is a special variable, which can hold more than one value of same data type. There are multiple ways to define an array. We will look at some of them. Array definition is similar to JavaScript, just you need to define the data type. We have seen 4 ways to define an array using square brackets, using array types, using array constructor and using array of keyword. For now, let's proceed with one of them and look at some of the famous methods. Later, in this video we will look at map, filter and reduce method. Push keyword is used to add values at the end of the array. Like, in this case we are pushing a value Saurav at the end of the names array. Similarly, pop method is used to pop out the last value of the array. Now, we will learn how to traverse an array using various types of for loops like for loop, for of loop, and for each loop. Oops, I missed the let keyword before n. Now, let's look at the most important, which is for each loop. Now, it's time to learn the 3 most important methods of an array, which are map, filter and reduce. Map creates a new array by transforming each elements of the original array. Filter creates a new array that includes only elements that pass a condition. Reduce processes the array and reduces it to single value. Let's understand more deeply through demonstration. Here, map created a new array with the double values of num. Here, we applied a filter which will store only those values which are divisible by 5. Here, in reduce, it will return a total sum of the entire num3 array. When we talk about tuples in TypeScript, a tuple is a typed array with a predefined length and types for each index. Tuples can be named tuples. Named tuples allow us to provide context for our values at each index. Let's understand this with a quick demonstration. Here, in this example you can see we have explicitly defined the data types of the tuples. Also it is important to maintain the sequence of values in the format it is defined. According to the example, the sequence is number, then boolean, and then string. So, this sequence should be maintained properly. Similar to arrays, you can also modify the values of tuple. You can also set tuple to read only, which will stop you from further modification in the tuples. This property is common for arrays as well. As we have discussed, we can also set context for each values in a tuple which will make it a named tuple. Next concept we have object. Objects are fundamental data structures used to store collections of key-value pairs, also known as properties. In TypeScript, we get an extra advantage to explicitly define the types of the object properties. Let's deep dive and look into the demonstration. Objects also allows to modify the values initialized, but with a condition that the new value should match its type. As you can see, if we try to modify the value of full name with a number value, it throws error. This is the characteristic of TypeScript, called type inference, as we have discussed in our previous videos. Additionally, for objects we can also explicitly define the value types. Now, let's learn how we can define optional properties in an object. You can see as we have removed the channel property, there is an error line showing under obj. You can make any property in an object optional by adding a question mark after the property name. Once a property is marked as optional, it's completely up to you whether you want to assign a value to it or leave it undefined. Now, let's proceed and learn how to define a nested object. Nested object means object inside an object. Here, it is showing an error, which tells us to define the type of the nested object. So, let's fix it. TypeScript offers many advantages over plain JavaScript, as we've been discussing throughout this course. In this video, we'll explore a special data type that is unique to TypeScript, enums. Enum stands for enumeration. An enum allows you to define a set of named constants. It helps make your code more readable and manageable by assigning friendly names to numeric or string values. There are different types of enums in TypeScript, including numeric enums. TypeScript assigns auto-incremented numeric values starting from 0 by default. String enums. In these, each member is assigned a constant string value. Heterogeneous enums. These enums contain both string and numeric values. Let's understand each types one by one with proper demonstration. We use enums when we have a set of related constant values that we want to group together with meaningful names. For example, here we have taken direction, which can be any of the following: north, south, east or west. As we have not assigned any values to any enum members, TypeScript assigns auto-incremented numeric values starting from 0 by default. Let's check it out through console.log. TypeScript enums are not natively supported in JavaScript, so the compiler has to generate extra code to simulate enum behavior. Thus, you can see complex functions in JavaScript file. As we have not assigned any value to our enum members, TypeScript has assigned auto-incremented numeric values starting from 0 by default to our enum members. Now, let's assign some values to our enum members. Let's see a real-life application of enums. The auto-incrementation in numeric enums depends on the value of the first member. By default, if we don't assign any values to enum members, TypeScript initializes them starting from 0 and increments by 1. However, in this example, we've explicitly assigned the value 1 to the first member, small pizza. As a result, the remaining members are automatically incremented from that value. So the value of small pizza will be 1. Medium pizza will be 2 and large pizza will be 3. If you are not comfortable with functions in TypeScript, I have already uploaded it on this channel. You can check this TypeScript full course playlist. As you can see, we have created a menu system using number enums. Where on specifying the serial number from 1 to 3 you can get the price of the respective pizza. Next, let's see the demonstration of string enums. In string enums, each member is assigned a constant string value. Let us elaborate this to understand how we can use string enums in real life. our code runs perfectly well. We can actually get the string enums value. Now, let's understand heterogeneous enums. Here, you can see as we removed the value of yellow and positioned it at the top, its value automatically got initialized to 0. This means, within an enum, we can give the value of enum members both numbers as well as strings. This is called heterogeneous enum. Let's elaborate and understand heterogeneous enums in more details. You can see the value of color box enum now. It has number as well as string value for its enum members. Finally, let's see a real-life scenario how we can use enums. Enums can be used to create login systems, where you can differentiate between admin user and guest user. Let's implement it in our code and create a login system like that. You can see how we generated a perfect login system by using enums, which differentiates users between admin and guest. A type alias is like creating a custom name, alias, for any TypeScript type. A type alias gives a custom name to any valid TypeScript type, string, number, object, array, function, union, etc. Let's understand this through example. For that we will define a string type variable, channel. After that, we will see how we can create custom name for the string type. After we created a custom type alias called value for string type. Now, we are free to use it anywhere we need to define string. Boom! We are getting correct output. Let's try this with one more variable and data type. Now, let's create a type alias for number type. You can see defining type alias for different types is that easy. You might be thinking, what is the purpose of defining type alias, if we can directly define the exact type? Let's try defining type alias in objects and functions. After that you will get your answer. For objects, as we have learned in our previous videos, that for TypeScript it's a good practice to define the types of all object properties for type safety. So, we are creating an object person1 where we are defining the exact type name of all the properties. Person1 object is created, but what if we need to create multiple person objects with same properties? For that, we have defined all the types, which will make our code look lengthy and complex. As a solution of this, we can create a type alias for all the properties we are using, in order to simplify our code. You can also define any properties as optional by simply putting question mark after its name. As a result, it would be your choice whether you want to define that property in your object or not. Let's see how we can give type alias in case of nested objects. For defining the type alias, for the nested object you need to define the type alias above the line of the main object type alias. Now, let's see how to define type alias in case of functions. Here, we have created a function which will take two numbers as its parameter and return the sum of it. Similar to objects, as the more number of functions we will create with same parameter and returning time, we need to define the types of each parameter and returning type of the functions every time. So, in order to make things simple, we can separately define a type alias and use it wherever required. You can see how the code got simplified by using type alias. Our code runs fine and it is giving the correct output. A union type can be termed to a variable that can have multiple types value at the same time. Let's understand through example what do we mean by this. In this example, we have taken a variable of string type. But if in case we also need this variable to accept number types. How to do that? If we directly assign number value to the variable, it shows an error. This is where union types come into play. To assign any variable multiple types, simply, you need to separate it by or operator. Boom! This is how we can assign any variable as union types. Similarly, we can do the same with more variables like boolean, begint, etc. Now, let's understand how to merge the concept of union types and type aliases together. Let's see one more example of contact info to understand the concepts of union types. Let's see something new. Let's elaborate the concept of type alias. This is how we usually write type alias, but do you know? We can create a string literal using which we will allow only a particular string to be accepted, like, in this case it will only accept pro-developing champs and nothing else, wherever we will use value as a type alias. You can see whenever we are trying to define some new values in myval other than pro-developing champs, it is showing some error lines, but when we set the value to pro-developing champs, the error disappears. Let's understand this alias feature through one more example. Here, a new type alias is created with 3 different string literals separated by union types. This means any of the 3 values can be used wherever make payment is defined. Followed by which we are defining a function shopping where we have passed a parameter, pay, of type make payment. This means that the variable, pay, will only accept those 3 values that are already defined in makePayment alias. Let's check it out through calling the shopping function. You can clearly see how that on passing all the above predefined string literals, our code runs well. But if in case we will use any other parameter, it will show error. Like, here as we passed gold as the parameter, it started showing error lines because it was not defined in makePayment alias. An interface in TypeScript is used to define the shape of an object. It tells TypeScript what properties and methods an object should have. Let's understand through example what do we mean by this. In this example, we have created an interface square with properties like side and color. This means any object of type square must have side and color property. Interfaces are generally used as an alternative of type alias, which we have already covered in our previous videos. Followed by defining interface, we have created an object mySquare of type square which has side length as 12 and color as red. While we are using interfaces, we can also apply the concept of inheritance in it using the extend keyword. As explained, we have created a new child interface, square area, which inherits the property of its parent interface, square. Now, in order to use the area property, we need to create an object of type square area. Let's see one more example of interface to understand it more accurately. This time we will create an interface person where a person must have its properties like name, age and a method greet. Followed by which, we are creating a object me of interface type person and defining its properties and methods. Our code runs correctly. Now let's apply the inheritance concept to our interface. Our code is running fine. In this video, you have seen that how we could use interface in place of type alias effectively. As we discussed earlier, a class is a blueprint for creating objects that share the same properties and methods. Let's see a quick demonstration of it. This is the basic structure of a class, with a constructor and a function. Let's create an object for this class person. Our code runs correctly. This was just a basic demonstration of class in TypeScript. Now let's understand access modifiers in details. Access modifiers define how class properties or methods can be accessed either from inside the class, outside the class, or from subclass. We have a list of access modifiers. Let's see one by one. First we have public. A public modifier is set by default. Accessible anywhere, inside the class, outside the class, and in derived classes. Let's see a quick demonstration. Next we have private modifier, accessible only inside the class and not outside or child classes. To access it outside we need to create getter and setter. Let's see a quick demonstration of it. Unlike public access modifier, private could not be accessed or modified directly. For that we need to create getters to fetch values and setter to modify value. You can see we were able to access the private value through getter, but if we try accessing the value directly, it will throw error. Next we have protected, which is accessible only inside the class and its subclass. Since it is set protected, so we are unable to access it directly just like private, but in this case we cannot create getter, we need to create a subclass to access the value. You can clearly see, dog barks meow. Last one we have is read only. Read only is not an access modifier, but it is used with them. By using this we could only read the data but could not update it. As explained, on printing the value it is fetching the exact value. Let's try updating it. As you can see, we can console.log the value of read-only variable but could not update it. But, if it would be some other modifier like public, we can easily update the value of public modifier. As the first pillar we have encapsulation. Encapsulation is about bundling the properties and methods into a single class. It also involves restricting access to certain details of an object using private, protected, and public access modifiers. Let's understand this through a quick demonstration. This keyword represents this variable. As you can see, using private access modifier we have encapsulated balance property inside the class bank account. So to fetch the details of balance we need to access it using getter method getBalance. Moving on to the second pillar of OOPS, which is abstraction. Abstraction means showing only the essential features of an object and hiding the background details or implementation. In order to implement abstraction, first we need to understand the concept of abstract classes. An abstract class is a class that cannot be instantiated directly. It is designed to be inherited by other class. It can contain two methods. Abstract method, which cannot be implemented directly inside abstract class. Concrete method, which can be implemented directly inside abstract class. Let's implement it in our code and understand this more effectively. This is a demonstration of how we write abstract class in our code. Next we will see the demonstration of concrete and abstract method. As you can see an error line in the abstract method, this is because we cannot write implementation of abstract method within abstract class. Also, as discussed, we cannot instantiate or create objects for an abstract class directly. For that we need to apply inheritance. As name is set to private, so it is showing error. As you can see, we have been able to apply the property of abstraction using abstract class and inheritance. Inheritance allows a class to inherit properties and methods from parent class. We implement inheritance using extend keyword. Just now we have seen its demonstration in the previous abstract class example. Let's create one more subclass as cat for the parent class animal. Fourth and last pillar we have as polymorphism. Polymorphism allows objects to be treated as instances of their parent class but behave differently based on the actual class. There are two types. Compile time, method overloading, not directly supported in TypeScript. Runtime, method overriding, supported by inheritance. Let's see an example or method overriding, as method overloading is not supported in TypeScript. You can see on inheriting the parent class, shape, for each of its subclass, we are overriding the method draw, which shows polymorphism. As each subclass like circle and square is behaving differently based on the parent class. Shape class draw method is drawing shape. Circle class draw method is drawing circle, and square class draw method is drawing square. Generics allow you to write reusable, flexible, and type-safe code by allowing types to be passed as parameters to functions, classes, interfaces, etc. Instead of hard-coding types, we use placeholders that are filled in when the code is used. Let's understand through some examples. Before actually looking into the generics, let's first create a function with which will take a string parameter as input and will return string. Our code runs fine. Now what if we pass a number value to the function instead of a string? As the return type and parameter type is defined as string, so it is showing error that number is not assignable to parameter of type string, so to fix it we will use any type. Here comes the use of generics. In the place of specifying the type, you can use placeholders like anything as per your comfort. In this example, we are using T. Generics make our code reusable, so we can use multiple types while passing the value of the parameter. In the place of T you can use anything as placeholders, but you need to specify it again and again as shown. Our code runs fine. Going more deeper into the concept, let's understand how to use extend keywords in generics. In this example, we are trying to print the length of the string which is passed as the parameter. Since length of the string is of type number, thus, it is showing error line. In order to fix it we will use extend keyword. Now let's see an example, where we will see how to use generics for multiple types. But before that we will write a function that will take string and number both as an argument. Boom! Our code runs fine. Now let's update our code using multiple generics. Now let's see an example of generics with arrays. Now let's see an example of generics with classes. The best part of using generics is that our code is reusable and it can be used more multiple types as well. Casting in TypeScript is a way to tell the compiler to treat a variable as a different type than it was initially inferred or declared to be. This is particularly useful when you have more information about a variable's type than TypeScript is aware of, such as after interacting with external data or APIs. There are two main syntax for casting. First is angle bracket syntax and second we have is as syntax. Let's understand through a quick demonstration. Initially, we have initialized a variable value using any type. Although we clearly know that the variable value is of type string, still we have assigned it as any. Followed by which, we will use angle bracket syntax way of casting to treat this variable as string. We will tell TypeScript to treat this value as string and get its length. There we go. Although you will not be using casting most often, still it is good to learn. Next, let's look at the other syntax of casting, which is using as keyword. Same as before. Let's change the string value with some other value and check. Done. Note, casting does not change the type of any variable. For example, if we will change the value of the variable with number and tell TypeScript to treat it as string, it will throw undefined as output. Now let's see where we can use casting as a real-life application. Suppose you want to use any HTML element value and you better know the value type of the HTML element. In this case you can use casting concept. Here, you can see we are using this HTML element as HTML input element. Casting is something which you will not be using regularly, but you should know it while coding TypeScript. First, let's look at the definition of KeyOf. KeyOf is a keyword in TypeScript that is used to extract the key or property type from an object type. What does it mean? Let's understand through an example. First, let's create an object, me, where we will define two properties as name and age. Now, as in our previous videos, we have learned the concept of type alias, where we used to separately define the types of the variable and objects. Till now, it is what we have already discussed in our previous videos. Now, let's move on to the concept of KeyOf. We have defined a variable and set its type to be the keys of the person type. This means the variable can only hold values that match the property names of person. In our case, the valid values are name and age. If we try to assign any other value, TypeScript will show an error. But, if we add the particular key channel inside our type alias, the error line will disappear. Similarly, as you can see, whenever we are trying to give some other values other than what is present in the key of type alias person, it is showing error. As we have seen, in TypeScript, the KeyOf operator takes an object type and produces a union type of all its property names, keys, as string or number literal types. So, what does string literals and number literals mean? Let's understand through an example. In this example, as we have set the type of this variable as Amit Kumar, now it will not accept any other value other than Amit Kumar. Whenever we will try giving some other value to the variable, it will show error. Note, while assigning the type as Amit Kumar, we are not setting the value of the variable. It's just fixing the value to that particular type. Same in the case of numbers as well. Now, let's see how we can bring KeyOf in use. We will create a function that will take an object of type person and a variable which will contain all the key values of type person. By using these two parameters, we will try to print the values of each key property of object, me. As function body is written now, let's call the function. Boom! As you can see, it has given us the value of key channel from the me object. Similarly, we can fetch the value of any object keys. Moving on to the definition of utility types. Utility types are the types which can help with some common type manipulation. There are many types of utility types. Some of the popular ones are: first one we have partial, that turns all the properties in an object to be optional. Let's understand through an example. We will create a type alias person for an object, and followed by which we will create an object of type person. What if we do not define any property for this object? It will show error. But using partial utility types, you can make all the properties of an object of type person as optional. As you can see, as we have set the value of me object as partial, now all the properties of type person is optional. It doesn't matter whether we give the values or not. Moving on to the next utility types, which is completely opposite to it. Required. It turns all the properties in an object to be required. Let's understand through an example. Same in the previous example, if we replace the partial keyword with required, now all the properties of the object has become mandatory. If we add any new property to the type person and set it to optional, then also we have to define it, because the required keyword has made it mandatory. Moving on to the next utility types, which is record. Record is a shortcut to defining an object with specific key type and value type. Let's understand through a quick example. In this example, we have set the value of key as string and value as number. Now, if in case we give the value as any string value, then it shows error. Next utility types we have is omit. Omit removes keys from an object type. How? Let's understand through a quick demonstration. As you can see in this example, we are telling Typescript to omit two properties from object Suresh. This will remove these two properties from the object, and as a result, now if we define the values of either age or channel, it will throw error. Next utility type we have is pick. Pick removes all but the specified keys from an object type. Pick works exactly opposite to omit. Here, we only define those properties only which we want to define values of. As in this example, we are only picking age property, which means now we only have to define the value of age. If in case we define the value of other properties like name and channel, it will throw error. Next, utility type we have is exclude, which removes types from a union. Let's understand through an example. In this example, we define a union type primitive that can be string, number, or boolean. Using the exclude utility type, we can remove a specific type from this union. Here, no string can only be number or boolean. This means variables of type noString cannot be assigned a string value. The same rule applies when excluding other types from the union. Next utility type we have is return type, which extracts the return type of a function type. Let's understand through an example how it works. Similar to the previous utility type, we have other is parameter, which extracts the parameter types of a function type as an array. Let's understand through a quick demonstration. As we have two parameters, one of type number and other of type string, so we need to give the value of z in the form of array. Also, we can solely define the values by indexing it as 0 and 1. Same as we do in arrays. Here, index 0 will have type number and index 1 will have type string. Lastly, we have a utility type as read-only. Read-only is used to create a new type where all properties are read-only, meaning they cannot be modified once assigned a value. Let's see a quick demonstration of it. As you can see, while setting the utility type as read-only, now we cannot modify the property values of the object. That's all in this video. Hope I was able to make you understand all these concepts in a better and easy way. If so, do subscribe to this channel, like this video and leave a comment. I will soon see you in the next video. Thanks for watching.